2019 A-Level Combined Mathematics Paper 1 Part B question number 16. This question is being done outside of my normal schedule with a special request of user GAN-G6c. If you yourself have such special requests of videos of either questions or lessons, then post them in the comments down below or in the comments of my other videos, and I will most likely check them and make similar videos to this one in the future. Now moving on to the question, since this question is long, I'll do the first half of the question first, and after that, I'll read the second half of the question. Now moving on to the first half of the question starts with, write down the coordinates of the point of intersection A of the straight lines 12x minus 5y minus 7 equals 0 and y equals 1. So we have to find the coordinates of the intersection point of these two lines. After that, the question says, let L be the bisector of the acute angle formed by these lines. So what we are talking about here is the fact that when you have these two lines, they're going to be intersecting at a point, and at this point there are going to be two angles, an acute angle that's less than 90 degrees and an obtuse angle that's greater than 90 degrees. Now it is of course possible that these two angles are equal and both are equal to 90, but that will only happen if the two lines are perpendicular to each other, which in this case they are not. So given this, we are told that L is the bisector of the smaller angle, the acute angle. With this information, we are then asked to find the equation of the straight line L. Now after the question says, let P be a point on L, and given this, we are asked to show that the coordinates of P can be written as 3 lambda plus 1, 2 lambda plus 1, where lambda is an element of the real numbers. Now what's happened here is that this lambda is a parameter, and we have given here the coordinates of a point on L parametrically such that if x is equal to 3 lambda plus 1, then y is equal to 2 lambda plus 1. So we have to show that. Now to start off with this question, we can try to find the intersection point A of these two straight lines. Now that's actually quite easy here because one of the lines is just y equals 1. Now what this means is that this line is a horizontal line at the y value of y equals 1. So here the y coordinate is y equals 1. According to that, if we have another line going like this and an intersection point like so, this intersection point should also have the y coordinate y equals 1. So therefore this point could be given by x0, 1. Now for this, what we have to do is to substitute y equals 1 into the other line and find the corresponding x value for that line, and that value is going to be the corresponding x value for the intersection point of the two lines. So in this case, what we have to do is to take the two lines, which are the lines 12x minus 5y minus 7 equals 0 and y equals 1, and just directly substitute in y equals 1 into the first line. So doing so, we can see we get 12x minus 5 times 1 minus 7 equals 0, which simplifies down to 12x minus 12 equals 0, and taking this minus 12 to the other side, we get 12x equals 12, and dividing both sides by 12, we get x equals 1. Now what this means is that the x coordinate of the intersection point of the two lines is x equals 1, and therefore the intersection point is x equals 1 and y equals 1. So therefore the coordinate of that point is 1, 1. So we can say 1, 1 is the intersection point of the above two lines. And with that we can say, if the intersection point of these two lines is the coordinate A, then A must be given by 1, 1. And with that, we have found the exact point A. The coordinates of A are x equals 1, y equals 1. Now that we've done that, we can move on to the second part of the question, which says, let L be the bisector of the acute angle formed by these lines. Now as we know, whenever you have two lines of the form, let's say a1x plus b1y plus c1 equals 0 and a2x plus b2y plus c2 equals 0, if these two lines intersect at a certain point, then the two angle bisectors will be given by a1x plus b1y plus c1 divided by the square root of a1 squared plus b1 squared equals, and on the other side we're going to get plus or minus a2x plus b2y plus c2 divided by the square root of a2 squared plus b2 squared. Now this of course comes to the fact that any angular bisector is going to have its points being equidistant from the two original lines. So here we can see, if we take the absolute value of both sides, we get the formulae for the distances perpendicularly from a particular point to two other lines, which are the two original lines that we had. Since these two distances must be equal, we can see how this equation would give us the two perpendicular bisectors. The only reason there's a plus or minus here and not the moduli is because we only want one of them. In the case that is plus, we're going to get one of the angle bisectors, and in the case it's minus, we get another angle bisector. Now, in this particular situation, we can see we have two lines of 12x minus 5y minus 7 equals 0 and y equals 1. This line is already in the form we want, a1x plus b1y plus c1. So we can just directly write that line as 12x minus 5y minus 7 equals 0. However, the other line is not in the form we want. We need in the form a1x plus b1y plus c1 equals 0. So to do that, I can do is take this 1 to the other side. Doing so, I get y minus 1 equals 0, which I could write as 0x plus y minus 1 equals 0. So therefore, the a2 here is equal to 0, b2 is equal to 1, and c2 is equal to negative 1. So we can say, according to that, the angle bisectors of, which we write like capital T, the angle bisectors of these two lines are given by, and we can directly substitute our knowledge and say the first line is going to be 12x minus 5y minus 7 divided by the square root of these two numbers squared, which is going to be square root of 12 squared plus negative 5 squared equals plus or minus the second line, which is y minus 1, divided by the square root of a squared plus b squared, which is going to be equal to 0 squared plus 1 squared. So we have 0 squared plus 1 squared. Now simplifying this, we can see on this side we have 12x minus 5y minus 7 divided by, and on the bottom here we have the square root of 12 squared plus 5 squared, which we know is equal to 13. Since we know the triangle, the right angle triangle of 12, 5 is going to have a hypotenuse of 13. So according to that, the square root on the bottom here is 13. So we get divide by 13 equals, on the other side we get plus or minus y minus 1 divided by, and on the bottom here, this is just 1. So divide by 1. So according to that, we can see our two lines are 12x minus 5y minus 7 equals, and when I take the 13 to the other side, plus or minus 13y minus 13. So plus or minus 13y minus 13. So according to that, the two lines are 12x minus 5y minus 7 equals 13y minus 13, or 12x minus 5y minus 7 equals minus 13y minus 13, which is going to be minus 13y plus 13, because you have a minus minus, the minus minus cancels, leaving us with plus 13. So these are the two equations of the two angular bisectors of the above two lines. Now out of these two, one of them is the line we want, and the other one is something else that we don't want. To find them, what I'm going to do first is to simplify them to the form of ax plus by plus c equals 0. So doing that, we can see we get here 12x, and then minus 5 and minus 13 becomes minus 18y, and then minus 7, and then minus minus 13 becomes minus 7 plus 13, which is going to be plus 6 equals 0. And simplifying, we can see we have 2x minus 3y plus 1 equals 0. So this is one of the lines of the angle bisectors. The other line is going to be the simplification of this line, which is going to be 12x, and then this minus and this thing to the other side is going to become plus 13. So we get plus 13 minus 5, which is going to be plus 8. So plus 8y, and then minus 7 and minus 13 becomes minus 20 equals 0, which simplifies down if we divide everything by 4 to 3x plus 2y minus 5 equals 0. So one of these two lines is the line we want, and the other one is not the line we want. So out of these two, in order to find the line that we want, what we can do is to consider the properties of the line L. Now the line L bisects an angle that is less than 90 degrees. It is something less than 90 degrees. Due to this, since the angle here is less than 90 degrees, if we divide it in half by bisecting, then the angle in between the line L and either one of these two lines is going to be an angle less than 45 degrees. So this angle here is less than 45 degrees. Now what we know about an angle like this is that you take its tangent. The tangent of this angle, let's say this angle is theta. Tangent of theta is definitely going to be less than tangent of 45, which is 1. So the tangent of theta must be less than 1 for the angle that is in between the line L and either one of these two lines. Now considering the other angle bisector, this angle bisector is going to be greater than, bisecting an angle greater than 9 degrees, and therefore the angle in between here is going to be greater than 45 degrees. So according to that, we call this angle x, then tangent of x must be greater than tangent of 45, which is 1. We can use this in order to check which of these two lines is the correct line. We can check the angles in between the line L and each of these two lines, or just one of them. We can check y equals 1 because that's simpler, and then we can see out of those two which one gives a value of tangent that is going to be less than 1, and that is the line L. So out of these two, one will give a tangent less than 1 and the other will give a tangent greater than 1. Now in order to find this tangent, what we can do is use the formula that states when you have two lines intersecting where one line has gradient of m1, so it's m1x plus c1, and the other line has gradient m2, which is m2x plus c2, then the angle in between them, let's say, is theta. Tangent of theta is equal to the modulus of m1 minus m2 divided by 1 plus m1 m2. We can use this formula here in order to check out of these two lines which one is the correct line. Now to do that, I can use either of the lines and the line L, but in this case I'm going to use the line y equals 1 and the line L, since y equals 1 is simpler than 12x minus 5y minus 7 equals 0. Now considering that line of y equals 1 has a gradient of 0. So gradient equals 0. Considering the other two lines here, the above line has a gradient of, and if we consider this line, if we take this 3y to the other side, we have 3y equals 2x plus 1, and dividing both sides by 3, we can see y equals 2 over 3 x plus 1 over 3, and therefore the gradient here is 2 over 3. Now considering the other line, the gradient of this line, gradient is equal to, and if I take the 2y to the other side, we have minus 2y, and if I divide both sides by minus 2, we get minus 3 over 2. So therefore the gradient here is minus 3 over 2. So the gradient of the first line is 2 over 3, the second line is negative 3 over 2, and y equals 1 has the gradient of 0. So according to this, applying our equation, if the angle between y equals 1 and L is theta, tangent of theta must be less than 1. And we also know tangent of theta equals modulus of m1 minus m2 divided by 1 plus m1 m2. Now to do this, we can either substitute the first line or the second line and check which one of them has a tangent that is less than 1. So let's try the first line. Let's try the line 2x minus 3y plus 1 equals 0. So we're going to do try, we'll write it like this. I was going to write it in the gradient intercept format, but we just write it like this. 2x minus 3y plus 1 equals 0. Try 2x minus 3y plus 1 equals 0. Now trying this one, we get tangent of theta equal to modulus of, and if we take m1 as this one's gradient, which is 2 over 3, we have 2 over 3 minus m2, which is 0, divided by 1 plus m1, which is 2 over 3, times m2, which is again 0, since the gradient of this line is 0. So times 0. Simplifying this down, we can see we get 2 over 3 on top, divided by 1 on the bottom, and the modulus that is simply 2 over 3. So the answer is 2 over 3, which is clearly less than 1. Now since this value is less than 1, we can conclude that the angle must be less than 45, and therefore this line is in fact the line L. Now in the case that this didn't happen, in the case we got some value that's greater than 1, let's say we got 4 over 3 or something. If we got 4 over 3 and this value is greater than 1, then what we'd have to conclude is that this line is not the line we're looking for, and therefore the other line of our two choices must be the angle bisector of the acute angle. But in this case, we didn't get that. We directly got a value that's less than 1. And therefore, the line corresponding to that, which is the line of 2x minus 3y plus 1, is the line L. So we can say, therefore, L is given by that line, which is 2x minus 3y plus 1 equals 0. And with that, we have also found the equation of the line L. Now going up, moving on to the next part of the question, it says, let P be a point on L, and given that we are asked to show that the coordinates of P can be written as 3 lambda plus 1, 2 lambda plus 1, where lambda is a parameter and element of the real numbers. Now for this, we need to get this equation into a parametric form. Now if we just consider the parametric form we have here, we have x equals 3 lambda plus 1 and y equals 2 lambda plus 1. Now if we simplify both of these to get lambda as a subject, on the left hand side we get x minus 1 equals 3 lambda, and therefore lambda equals x minus 1 over 3. Simplifying this one we get y minus 1 equals 2 lambda and lambda equals y minus 1 over 2. According to that, we want to try to get our equation for the line L into the form x minus 1 over 3 equals y minus 1 over 2. This is the form we need to get in order to say this is equal to lambda and then find these two parametric equations. So according to that, we can go down and try to rearrange our line L into the form of x minus 1 over 3 equals y minus 1 over 2. So going down, let's try and do exactly that. So we're going to start with the line we already have, which is the line of 2x minus 3y plus 1 equals 0. Now in our parametric form, we need x to be on one side of the equation and y to be on the other side. So therefore, let's directly take everything of y's to the other side. So doing so, if we go down here, we can get from the line L the equation 2x plus 1 equals 3y. Because if we take the minus 3y to the other side, we get plus 3y. So we get this equation right here. But we don't want this. We instead want x minus 1 divided by 3 equals y minus 1 divided by 2. So to achieve that, I'm going to subtract 3 from both sides. So doing so, I can get 2x plus 1 minus 3, which is minus 2, equals 3y minus 3. And now we can see, if I divide both sides by 2 and also divide both sides by 3, on the left hand side I'm going to get this 2 cancelled and then divide by 3, which is going to be x minus 1 divided by 3 equals, on the other side, if I divide by 2 and divide by 3, the 3 cancels and I have y minus 1 divided by 2. So we get y minus 1 divided by 2. And therefore I can say, let lambda be an element of the real numbers, and given that, I can say x minus 1 divided by 3 equal y minus 1 divided by 2 equal lambda, and from this I can take this part and this part separately to get x minus 1 divided by 3 equals lambda, and from this part and this part I can get y minus 1 divided by 2 equals lambda. And simplifying both of these down, we can see on the left hand side we get x minus 1 equals 3 lambda, and therefore x equals 3 lambda plus 1, and on the other side we get y minus 1 equals 2 lambda, and therefore y equal 2 lambda plus 1. 2 lambda plus 1. And with that, we have our two parametric equations. So now we can say, therefore, if a point P lies on the line L, P can be given by and we can write P given by these two coordinates instead of x, 3 lambda plus 1, and instead of y, 2 lambda plus 1. And with that, we are done with the first part of the question, because we have shown that the coordinates of intersection A of these lines are 1, 1. We have found the line L, and we have also found that the coordinates of P, which is on the line L, can be given by 3 lambda plus 1, 2 lambda plus 1, where lambda is an element of the real numbers and a parameter. So now, let's move on to the second half of this question. So at first, this part of the question says, let the point B be given by 6, 0, and given this, we are asked to show that the equation of the circle with the points B and P as ends of a diameter can be written as s plus lambda u equals 0, where s is the same thing as x squared plus y squared minus 7x minus y plus 6, and u is the same thing as minus 3x minus 2y plus 18. After that, we're asked to deduce that s equals 0 is the equation of the circle with AB as a diameter. And then it says, show that the equation u equals 0 is the equation of the straight line that goes through the point B and is also perpendicular to the line L. After this, the question says, find the coordinates of the fixed point which is distinct from B, so not B, any other point that's not B, but is also lying on the circles with equation s plus lambda equals 0 for all lambda element of the real numbers. The question then says, find the value of lambda such that the circle given by s equals 0 is orthogonal to the circle given by s plus lambda u equals 0. So for a particular value of lambda, this will hold true. Now, to start off with this question, let's try to find the circle with the equation such that B and P are both ends of a diameter of that circle. Now for this, what we know is that given a circle, let's say this circle, with two diameter endpoints of let's say x1, y1 and x2, y2, if the circle here is S, then S is given by the equation x minus x1 times x minus x2 plus y minus y1 times y minus y2 equals 0. Given two endpoints of a diameter, this is the equation for the corresponding circle. Now applying that to this situation, what we have to do is to take the coordinates of B and P and substitute them into that equation in order to find the circle that we want. So let's say, let the circle S dash be the circle that has B, P as endpoints of one of its diameters. Now given that, if we consider the coordinates of B and P, B is given by 6, 0 and P is given by the parametric which is 3 lambda plus 1, 2 lambda plus 1. And therefore, if we substitute, we can say S dash must be given by x minus x1, which is x minus 6, times x minus x2, which is x minus 3 lambda plus 1, plus y minus y1, which is 0, times y minus y2, which is 2 lambda plus 1, equals 0. So this must be the equation of the circle S dash. Now in this equation we can see we have some normal terms, but we are also going to get some terms that contain lambda. And this is what we want, since in our final equation we need to have some terms that are just normal and some terms that have a lambda inside of them. So according to that, if we simplify, we should get the equation that we had above. So if we start simplifying here, we can see we get x times x, which is x squared. We get x times minus 3 lambda, which is going to be minus 3 lambda x, and then we get minus 6 times x, which is minus 6x, and then x times minus 1, which is minus x, which is going to culminate into minus 7x. Minus 6x plus minus x is minus 7x. And then we're going to get minus 6 times minus 3 lambda plus 1, which is going to become plus 18 lambda, and then minus 6 times minus 1 is plus 6. And then we're going to have y times this stuff, which is going to be y times y, which is y squared. And then we're going to have y times this bit here, which is y times minus 2 lambda, which is minus 2 lambda y. And then y times minus, this is supposed to be minus plus 1 here. This looks like a 7 or something. I'm just going to correct that quickly. This looks like a, there we go, right. So we have y times minus 1, which is minus y, and therefore we get minus y, and that is equal to 0. Now considering all of the terms here, we can see we have some normal terms in the x squared, the minus 7x, the plus 6, the y squared, and the minus y. But we also have some number terms in the minus 3 lambda x, minus 2 lambda y, and the plus 18 lambda. So if we sort them, we get x squared plus y squared, and then minus 7x and minus y and plus 6, and we sort out the lambda terms and take out lambda, we can write that as plus lambda times, and on the inside we get minus 3x minus 2y plus 18, and that is equal to 0. So this is the equation that we get. Now going up, we can see s was given by x squared plus y squared minus 7x minus y plus 6, and u was given by minus 3x minus 2y plus 18. And if we go down, we can see we have exactly that. On the outside here, we have this bit, which is exactly what we called s in our question. So therefore this is s, and this bit right here is u. So we have s plus lambda times this part here, which is u, and that is equal to 0. So therefore we get s dash given by s plus lambda u equals 0, where, and we can write s is equal to, or s is given by x squared plus y squared minus 7x minus y plus 6, comma, u is given by minus 3x minus 2y plus 18. And with that, we have solved the first part of the question. Now moving on to the next line, it says deduce that s equals 0 is the equation of the circle with AB as a diameter. Now if we consider the equation that we have here, we have s dash given by s plus lambda u equals 0. Now if we have s equals 0, the only way that s, this bit, is equal to 0 is if the other part here is also equal to 0. So therefore lambda u must also be equal to 0. So we can say if s equals 0, then lambda u is also equal to 0. Now considering this, if lambda is equal to 0, we have one situation. But if u is equal to 0, we have another situation. But considering u equals 0, we can see, since u is a line as given in the question, we are going to have multiple different possible solutions for u equals 0. However, if lambda is equal to 0, then all of that goes away, and we have just lambda equals 0 in this entire equation, meaning the whole thing is equal to 0, and then we have just s dash given by s equals 0. So therefore, if this is the case, then lambda equals 0 is a possible solution, and from lambda equals 0 we can see lambda equals 0 will correspond to s dash given by s equals 0. So therefore the equation of the circle s dash is going to be correspondent to s equals 0. Now if we consider lambda equals 0, lambda is related to the point P, and from the point P we can see, if we substitute lambda equals 0 into P, P is given by 3 lambda plus 1, comma 2 lambda plus 1, which is substitute lambda equals 0 turns into P given by 0 plus 1, comma 0 plus 1, which is 1 comma 1, which is exactly the point A as we found previously. So the point P turns into the point A when we get lambda equals 0. Now considering lambda equals 0, since s dash, we can say since s dash has diameter of PB, and since P is the same thing as B when lambda equals 0, i.e. s equals 0, we can say s equals 0 corresponds to the circle with diameter, and instead of P, since P is the same thing as, sorry, not actually, I made a mistake here, not B, P is the same thing as A, I apologize for that, P same as A as we found here, then since P is same as thing as A, when lambda is equal to 0, i.e. s equals 0, then s equals 0 must be corresponding to the circle with the diameter, where instead of PB, we have P the same thing as A, and therefore the diameter is AB. So we can say the circle s equals 0 must correspond to the circle with the diameter of AB. And with that, we can conclude this part of the question. Now, what we've done here, this argument is valid and sufficient for saying that s equals 0 corresponds to the circle with the diameter of AB. However, of course, if you like, you can add a little bit more to this. But for my purposes, I think this is going to be sufficient. So now, let's move on to the next part of the question. The next part of the question says, show that u equals 0 is the equation of a straight line that goes through the point B and is perpendicular to L. Now there are two ways to do this. One way is to try to find the equation of the line that goes through the point B and is perpendicular to L and show that that line is the same thing as u equals 0. The other way to do it is to take the line u equals 0 and check if it passes through the point B and also check if it's perpendicular to L. And if those two conditions are true, then the line u equals 0 is the line that passes through the point B and is perpendicular to line L. Now I myself found the second method easier, so therefore I'm going to try the second method. I'm going to take this line equals 0 and I'm going to see if that line passes through B and also if it's perpendicular to L. Now considering that, if we consider u equals 0 is correspond to the line, and if I take the equation of the line u, I get minus 3x minus 2y plus 18 equals 0. So we get minus 3x minus 2y plus 18 equals 0. So this is the line corresponding to u equals 0. Now from this, what we can do is to check whether this line is going through the point B and also check whether this line is perpendicular to the line L. Now first off, if B is on u equals 0, then the coordinates of B, which are 6, 0, must satisfy u equals 0. So we can just check by substituting x equals 6 and y equals 0 and see if those two coordinates satisfy u equals 0. And we can see by substitution, if we take this equation substitute, we get minus 3 times x, which is 6, minus 2 times y, which is 0, plus 18, which is equal to minus 3 times 6, which is minus 18, and then this is 0 plus 18, which is in fact equal to 0. Minus 18 plus 18 plus 0 is equal to 0. And therefore we get 0. And therefore, since B is on the line u equals 0, it satisfies u equals 0, and therefore B is on u equals 0. And therefore u equals 0 passes through the point B. Now other than this, we also need to check if u equals 0 is perpendicular to the line L. Now for that, we can find the gradient of u equals 0. So gradient of u equals 0 is, and if we take a look at our equation, we have minus 3x minus 2y plus 18. If we take the y to the other side, we get plus 2y equals minus 3x plus 18. And dividing both sides by 2, we get y equals minus 302x plus 9. And therefore, our gradient is minus 302. So the gradient here is minus 302. Now as we know, when you multiply two gradients together, let's say m1 times m2, and it's equal to negative 1, then the two lines are perpendicular to each other. Now according to that, if I take this value and the gradient of L and I multiply them together, if they are perpendicular, I will get negative 1. So I can check that by taking the gradient of L, which as we found above was equal to 203. So therefore the value we get here is 203. Now considering these two, if you multiply them, minus 3/2 times 203 gets us minus 1. Since this 3 and this 3 cancel, and this 2 and this 2 cancel, leaving us with just minus 1. And therefore the value here is minus 1. Now since these two gradients multiplied together is minus 1, we can say that our two lines of u equals 0 and L must be perpendicular to each other. So we can say, therefore, u equals 0 and L are perpendicular to each other. Now, these two conditions that we found are two separate conditions. The first condition is that B is on u equals 0. I'm going to call that condition A. The second condition is that the line u equals 0 and the line L are perpendicular to each other. Now question asks us to show that both of these are true for u equals 0 at the same time. U equals 0 has the line L perpendicular to it and also goes through the point B. So both of these are true from A and B. So therefore if we take equations A and B, or rather conditions A and B, and combine them, we can say u equals 0 passes through B and is perpendicular to line L. And with that, we are done with that part of the question as well. Now we can move on to the second part of the question. The next part of the question says, find the coordinates of the fixed point which is distinct from B and lying on the circles with the equation s plus lambda equals 0 for all lambda elements of the real numbers. So for this part of the question, we need to have the following knowledge on circles. We need to know that if you have a circle s equals 0 and the line u equals 0 that intersect at 2 points like so, then any other circle that passes through these two same points, like this circle right here, must be a circle of the form s plus lambda u equals 0, where lambda is an element of the real numbers. And only circles of this form will pass through both of these two intersection points. Now, according to this, if we consider what the question said, which is that we are asked to find the distinct point from B that is also lying on the circles with the equation s plus lambda equals 0 for all lambda elements of the real numbers, according to that, one of these 2 points must be B and the other point is the point we're looking for. So given the circle s equals 0 and the line u equals 0, we know that one of the intersection points of these two lines of this line and circle rather is going to be the point B, and the other point is the point we're looking for, since those 2 points are the only 2 points that are lying on all of the circles of the form s plus lambda u equals 0 for all values of lambda. So out of these 2 points, one of them is B and the other point is some other point that we don't know. Since I've already used A, I'll call this point C. Now if we consider the circles here, the circle s equals 0 is the circle that had a diameter of AB. So according to that, if the point here is B, then opposite that point, we should have the other point A somewhere over here. So we have the A point here and the B point here, and the line AB is the diameter of the circle. Now with this, we just think about it for a second, we'll realize that if I draw the line AC and connect them with AC and BC, the angle ACB must be 90 degrees, since AB is a diameter and C is a point on the circle. Now this is actually much more useful than you might think, because this actually allows us to directly find the coordinates of the point C. You see, if we go up to the first part of the question had a line called L. Now L was the angle bisector of the two lines that intersected at the point A. Due to this, L passed through A. We also know down here that the line u equals 0 was perpendicular to the line L, as we found here. Line u equals 0 and line L are both perpendicular to each other. Now combining these two, if we consider this second line here, the first line we have is the line u equals 0, but the second line passes through the point A and is also perpendicular to the line u equals 0. Therefore, the second line here must be the line L. So this is the line L. And from that we can see the point C that we're looking for, the point that's distinct from B, but also is on every single circle of the form s plus lambda equals 0, is going to be the intersection point of the line L and the line u equals 0. So for this we need some explanation. So for this explanation I'm going to say, since s equals 0 and u equals 0 intersect at B and another point, and we'll say C, s plus lambda u equals 0 pass through B comma C for all values of lambda element of the real numbers. And with that we can also say, since s equals 0 is the circle with AB as a diameter, comma, C is on s equals 0, the angle ACB is 90 degrees. Therefore, AC line is perpendicular to the BC line. And with that, we can conclude what AC line is. Since L passes through A, comma, L is perpendicular to u equals 0, i.e. BC, since u equals 0 and BC are both the same line, because they are both, marked exactly the same, u equals 0 and BC are the same line, and therefore, L is the AC line. And from that we can derive that the point C is the intersection of L and u equals 0. Now considering line L was this line right here, the line 2x minus 3y plus 1 equals 0. 2x minus 3y plus 1 equals 0. So we can say according to that, 2x minus 3y plus 1 equals 0 must be satisfied by the coordinates of the point C. So if we substitute the coordinates of C into here, we should get a correct equation. Now we can also say, since the line u equals 0 goes through C, if we go up and consider line u equals 0, which is minus 3x minus 2y plus 18, minus 3y minus 2x plus 18 equals 0 must also satisfy C. So C is on, and C is on these two lines. So C is on this line and C is on this line as well. Now from that, if we combine these two, we can see if we, what can we do easily here? We can multiply this by 3 and multiply this by 2. So if we take this as equation number 1 and this is equation number 2, we can do equation number 1 times 3 plus equation number 2 times 2. And doing so, we can see, I made a mistake here. This is 3x and this is 2y. I apologize for that. This is minus 3x and minus 2y plus 18. So anyway, we can multiply it by 3 and multiply the other equation by 2. And doing so, we will get the x terms to cancel. So if you multiply by 2 and multiply by 3, we're going to get a total of 6x here and total of minus 6x here. So cancelling those two, what we're left with is 3 times minus 3y, which is minus 9y, and 2 times minus 2y, which is minus 4y, equals, on the other side we have 1 times 3, which is going to be minus 3, and 2 times 18, which is minus 39. Minus 36. So from that, the total on this side is minus 39, and the total on the other side is minus 13y. So therefore, we get the coordinate y equals minus 39 divided by minus 13, which is 3. So y equals 3. Now substituting back into equation number 1, we can find the corresponding value of x. So from that, we can see we get 2x minus 3 times 3, which is minus 9, plus 1 equals 0. So this substitute simplifies to minus 8. So taken on the other side is plus 8. So 2x equals plus 8. And from that, we get x equals 8 over 2, which is 4. So x equals 4 and y equals 3. So from these two, we can finally conclude that C is given by the coordinates of 4, 3. And with that, we have done that part of the question as well. Now we can finally move on to the last part of the question, which says, find the value of lambda such that the circle given by s equals 0 is orthogonal to the circle given by s plus lambda u equals 0. Now for this, we didn't know that if you have two circles of the form x squared plus y squared plus 2f1x plus 2g1y plus c1 equals 0 and x squared plus y squared plus 2f2x plus 2g2y plus c2 equals 0, then the two circles will intersect orthogonally if 2f1f2 plus 2g1g2 is equal to c1 plus c2. Now applying that to these two circles, the first circle is s equals 0, so we can write s equals 0, which is given by, and if I go up and copy the exact equation, it is x squared plus y squared minus 7x minus y plus 6 equals 0. So we're going down, we can write this here and say equals 0. Now the second circle is s plus lambda u equals 0, and that's going to be correspondent to this same equation, which is the equation of s plus lambda times u, which if we go up is lambda times the equation of the value u, which is going to be going up this line right here, minus 3x minus 2y plus 18. So we can copy that down and multiply that by lambda. So we can put that right here we don't have enough space, it seems, so I'll move everything to the left a bit, like so, and that is equal to 0. Now, the first equation that we have here is already pretty much in the format we want. We have x squared plus y squared, and then here we kind of have 2fx because we have 2 minus 7 over 2 x. So f here is minus 7 over 2. And for g here, we also have the same thing. We can take a 2 out and divide by 2 to get the coefficient we want. And c is just right here. However, for the second one, we don't have that format. You can see over here we have one x term, but over here we have another x term. Due to this, we need to factorize all the x terms separately and y terms separately and constant terms separately in order to get the coefficients that we want. We need to find f2, g2 and c2. So here I'm going to rearrange this as x squared plus y squared, and then here I'm going to put plus something times x plus something times y plus the constant something equals 0. Now factorizing here, we can see inside of the x something we have minus 7, and we also have a minus 3 times lambda over here. Now since I want 2 times f as this bit, I'm going to take a 2 out and preemptively divide everything by 2. So here I have minus 7 minus 3 lambda all divided by 2. Similarly for y, if I want to take a minus out, I'm going to have divide everything by 2, and if I consider what I have left, it is a minus 1 here and also a minus 2 times lambda here. So you have minus 1 minus 2 lambda divided by 2. And for the constant term, we just have all of the constant terms from this part and this part, which is going to be 6 plus the 18 times lambda here. So we can write 6 plus 18 lambda, and that is that. We now have the format we want. So here we have f1 equals minus 7 over 2, g1 equals minus 1 over 2, and c1 equals 6. And over here we have this as f2, this as g2, and this as c2. So therefore, our expression for these two circles being orthogonal is going to be if s equals 0 and s plus lambda u equals 0 are orthogonal 2 times f1, which is minus 7 over 2, times f2, which is going to be minus 7 minus 3 lambda over 2, plus 2g1 g2, which is going to be minus 1 over 2, times minus 1 minus 2 lambda over 2 is equal to c1 plus c2, which is 6 plus 6 plus 18 lambda. So therefore we get 6 plus 18 lambda. Now simplifying this down, we can see if we cancel this 2 and this 2 and also this 2 and this 2, all you have to do is to multiply both sides by 2. And doing so, we can see on the left hand side we just get minus 7 times minus 7, which is plus 49, and minus 7 times minus 3 lambda, which is going to be plus 21 lambda. And over here we get, if we cancel this 2 and take the other 2 to the other side, minus 1 times minus 1, which is plus 1, and minus 1 times minus 2 lambda, which is plus 2 lambda. And then on the other side we have 2 times 6 plus 6, which is going to be 12 times 2, which is 24, and 18 lambda times 2, which is 36 lambda. So we get this. Now simplifying this down, we can see on the left hand side we have 21 plus 2, which is 23 lambda. Taking the other side we have 36 minus 23 lambda, and on the other side we're going to have 49 and a 1, which is 50 minus 24. So we have 50 minus 24. Now simplifying this down, we can see on the left hand side we have 13, and on the right hand side we have 13 lambda and 26. So we get 13 lambda equals 26, and dividing both sides by 13 we get lambda equals 2. So therefore our final answer is lambda equals 2. Lambda equals 2 is the value of lambda for which the circles s equals 0 and s plus lambda equals 0 are orthogonally intersecting each other. And with that, we are done with this question. So now finally, let's go up and discuss the marks awarded for this question. So at the start of the question, when you find the coordinates of the point A like so using a valid method, you get 10 marks. After that, when you take the two lines and then you find the angle bisectors like so using the substitution, for writing the substitution correctly, you get 10 marks. After that, when you simplify down and you get the two answers, for writing each of the answers, you get 5 marks each. For writing first answer, you get 5 marks, and the second answer, another 5 marks. Now after that, when you take these two answers and take the gradients and then compare them with the tangent to see which one of them is the acute angle bisector, and you get either the tangent being less than 1, or if you pick the wrong one you get the tangent being greater than 1, you get 5 marks for that. And then using that result, when you identify which of the two is the correct one, which is going to be the one where the tangent is less than 1, you get another 5 marks for writing down L correctly. Now after that, when you take L and change this equation to this form so that you can make the parametrics and rearrange to get this, you get 5 marks for writing out this equation. And then when you rearrange each of the parts of this equation to get the parametrics for x and y, and then write the point P in terms of the parametric lambda, you get another 5 marks. Now after that, when you consider the circle S dash that has the 2 points B and P as endpoints of the diameter, and directly write the equation corresponding to that, which is x minus x1 times x minus x2 plus y minus y1 times y minus y2 equals 0, you get 10 marks for the direct substitution. After that, when you simplify a little bit, you get 5 marks, and then when you simplify further and rearrange to get S, you get 5 marks for S, and when you get lambda times U, you get 5 marks for lambda times U. And after that, when you then consider S equals 0 and see that when S equals 0, lambda is going to be equal to 0, and according to that, we must get the point P be given by 0 plus 1 comma 0 plus 1, which is 1 comma 1, which is exactly the same as A. For identifying that in this special case, the point P becomes A, you get 5 marks. Now after that, when you go down a little bit further and consider PB and say since P is given as A, the diameter of this circle is going to be AB, and therefore S equals 0 is a circle with diameter of AB, you get another 5 marks for making that conclusion. Now after that, for the U equals 0 line, when you simplify U equals 0 line, and if you use this method, when you get that B is on U0 by substitution, you get 5 marks. When you use this method and find that when you multiply them, you get -1, and therefore multiple of the grades being -1 means they are perpendicular, and therefore say U equals 0 and L are perpendicular, you get 5 marks. And then when you combine them to say U equals 0 is the line that passes through B and is perpendicular to L, you get 5 marks. Now if you didn't do that way, if you instead, built up the actual equation of U equals 0 using the information given, you would still get 15 marks in total, but you'd get them in a different way. So if you're interested, check out the mark scheme for that method. But anyway, this is my method, and this method gets marks like so. So anyway, moving on to the next part, when you try to find the point C, which is the other point other than B that is on every single circle that has of the form S plus lambda U, where lambda is a real number, equals 0, you get this whole thing. And for this, when you say that the points B and C, the only 2 points that stay on every single one of these circles, are the points that satisfy S equals 0 and U equals 0, or the intersection points of S equals 0 and U equals 0, for saying that, you get a total of 10 marks. Now after that, when you do a little bit of geometric simplification, and then you say, according to the geometry here, the point C must lie on L as well, and therefore the point C is the intersection of L and U equals 0. When you say that, you get another 10 marks. And after that, when you substitute the two lines into each other and find y equals 3 and x equals 4 to get the coordinates of the point C, you get another 5 marks. Now after that, when you do the final bit, which has to do with orthogonal intersection, when you write out the two circles and substitute into the equation correctly, for doing the 2f1 f2 plus 2g1 g2 plus equals c1 plus c2, when you substitute the two f's correctly, you get 5 marks. When you substitute the two g's correctly, you get 5 marks. And when you substitute the two c's correctly, you get another 5 marks. Now after that, when you simplify down and get the correct final answer of lambda equals 2, you get a final 5 marks, and that is the end of this question. So I hope you enjoyed. If you have any feedback, post them in comments down below. Thank you for watching, and goodbye.